Hey everyone, welcome to the Foundry by Forge College. Today's explainer is all about taking that, let's be honest, coffee-stained rough napkin sketch from our last lesson, Capstone Kickoff, Framework for Comprehensive Planning, and translating it into a highly detailed engineering-grade deployment blueprint. Because if your deployment plans usually feel a bit too theoretical, or if you literally break out in a cold sweat thinking about a 3 a.m. server crash, well, you are in exactly the right place. All right, let's quickly glance at our blueprint for today. We'll be covering 1. Framework to blueprint. 2. The golden triplet. 3. Real-world Solana scenario. 4. Automating the checklist. And finally, 5. Human versus machine plans. Let's jump right in. Section 1. From framework to blueprint, shifting our mindset. So look at this. This perfectly illustrates the massive gap between a useless generic idea and an actual concrete checkpoint. On the left, we've got monitor RPC latency, which, sounds great in theory. But try figuring out what that actually means when your launch is on fire and Discord is literally screaming at you. Now, on the right side, we have a precise specification. RPC P99 latency under 200 milliseconds measured over a 10-minute rolling window against the testnet. Boom! That is a hard, quantifiable threshold that a system, or a highly caffeinated human, can definitively test. Moving right along to Section 2, the golden triplet, the core blueprinting process. Okay, so to prevent that classic terrifying developer nightmare known as the not my job phenomenon, every single task has to be built on these 3 interlocking gears. You absolutely need an owner, which is a specific accountable role. You need a checkpoint, a small, highly testable verification gate, and you need acceptance criteria, meaning quantifiable pass or fail conditions. Without all 3 of these tightly locked together, your deployment machine simply won't run. Everyone's just going to stand around staring at each other when things inevitably break.
You see, pointing fingers when a deployment goes sideways doesn't fix a broken mainnet, right? Which is exactly why having explicit ownership and designated fallback contacts isn't just a nice to have, it's absolutely non-negotiable. Someone always needs to be holding the steering wheel.
Which brings us to Section 3, Real-World Solana Scenario, a Solana-backed NFT.
Let's put on our Chief Integrations owner hats for just a second. To actually test compatibility before going live, you can't just cross your fingers and rely on generic goals. You have to convert them into a strict 4-step process flow. Check out these gears here. Step 1, verify the CI artifact checksum. Step 2, provision an ephemeral testnet environment. Step 3, execute the deploy script. And Step 4, run an end-to-end smoke test. You're looking for 100% success across successive runs with absolutely 0 unexpected logs. This right here is how you guarantee the machinery actually works before exposing it to the wild.
But here's a really critical question for you. What happens when that smoke test fails on Step 2? I mean, sure, breaking a testnet so mainnet doesn't have to is definitely a victory. But it's only a victory if you actually have a prepared playbook for when these quality control gates inevitably fail. And that is where your fallback playbook comes in. For every single hard checkpoint, you have got to predefine a troubleshooting path. It needs a primary diagnosis step, like inspecting program logs or comparing program IDs, an immediate mitigation, say reverting to the last green artifact, and a very clear decision threshold for rolling back entirely and notifying your security reviewer. The absolute worst time to make these decisions is on the fly when the pressure is at a maximum.
All right, moving to Section 4, automating the checklist, enforcing the rules.
As you explore other programs and courses at Forge College, you'll quickly realize that manual processes are basically just open invitations for human error. They're the digital equivalent of someone saying, "Well, it worked on my machine." So we need an automated assembly line. Enter this brilliantly simple Python helper script. It just parses a YAML checklist to make sure these 4 essential fields, the item, the owner, the checkpoint, and the acceptance criteria, are literally never left blank. It's a tiny tool, but man, it enforces an incredible amount of discipline.
If someone forgets to assign an owner or just gets lazy and leaves the criteria blank, the script automatically injects missing markers and spits out a CSV report flagging all the incomplete items. By automatically catching these omissions, this tool drastically cuts down on silent gaps and missing owner errors way before you ever get to a facilitator review. It essentially forces your plan to be airtight.
Finally, Section 5, Human versus Machine, Plans, Dual Thinking. Ultimately, prepping operationally for a deployment means your checklist actually has to exist in 2 entirely different dimensions at the same time. First up is the human-readable format, like this one-page summary table right here. This is designed specifically for stand-ups and quick audits. It lists the item, the owner, the checkpoint, and the criteria in a super clean, minimalist way. It lets reviewers and your on-call colleagues quickly grasp the why and the who at a single glance without having to frantically dig through repos or code files.
But you also absolutely need the machine-readable version. The machine-readable side, your CI job definitions, deployment scripts, issue templates, that ensures absolute repeatability and acts as your unshakable source of truth for automation. Meanwhile, the human-readable table ensures your actual team can quickly coordinate. During a chaotic deployment window, you rely on the machine for precision and the human summary for rapid communication.
So I want to leave you with this fundamental challenge to think about. If your checkpoints are ambiguous today, how can your automated remediation ever be reliable tomorrow? It's the core problem you have to solve before we start building monitoring systems in our next lesson. It has been fantastic walking through this blueprint with you today. To learn more about the subject, master your Web3 deployment strategies, and explore more amazing learning resources, be sure to head over to forge.college. Keep building, stay focused, and I'll catch you in the next explainer.